everyone. Welcome to PowerKit AI webinars, and this is deep dive into generative orchestration part 1. And I'm going to be one of your speakers. I'm Ashley, and I'm going to be in the background helping with like polling and all of that. And then our speaker is Remy, and I'll let him introduce himself.
Hello, everyone. Good morning, good afternoon, good evening, wherever you are in the world. Thank you for joining us. My name is Remy. I'm a solution architect on the PowerCat team. I work on Copilot Studio, and I help customers be successful in deploying Copilot Studio at scale. So I do best practice guidance, implementation guide, those kind of webinars. So we help customer, and we also do some scaling to help the community and everyone who wants to dive into Copilot Studio.
Okay, so now we're going to get started into mastering generative orchestration, insights, and best practices. So the agenda is going to go, what is natural language understanding, generative orchestration architecture, generative orchestration deep dive, why generative orchestration is key, and then Q&A.
So before we dive into generative orchestration, we have to just step back 1 second. Like agents is like, what are agents? It's kind of a rhetorical question, because if you're here today, you kind of know what are agents. But the key here is the different complexity of those agents. And generative orchestration is part of that complexity, or is a feature to help address that complexity. Because you can have simple agents, like a retrieval agent, where you add knowledge and you ask a question, you just want that answer from a SharePoint library or from documents that you upload to your agent. All the way to the right to autonomous agents, which are designed to dynamically assemble different tools and topics and knowledge to act on your behalf and do something. But despite the wide variety of agents from simple to advanced, generative orchestration is there all the way, and you can use it for simple use cases, but you can also use it for very complex use cases. And that's what we are going to see today is, how do you use generative orchestration for those simple use cases, and what can it bring to those retrieval agents that classic orchestration is not able to handle, all the way to task agent and autonomous agent. And autonomous agent, we will see that later, generative orchestration is mandatory. You cannot work with an autonomous agent. You cannot develop an autonomous agent if you don't use generative orchestration. And we'll see why that matters and why generative orchestration is key in those autonomous agents. But before we go a little bit further, we have to step back. Also, one bit is to talk about natural language understanding, because all the agents that we have, like the retrieval agent, the action agent, the autonomous agent, they are all based on a similar concept, which is natural language understanding. So the ability of the agent to understand what the user is asking. So if I'm a user and I go to my favorite airline website, typically there will be a virtual agent sitting in the corner asking me if I need any help. And if you go there and you ask a question like, I want to book a flight to Paris next week, what the agent is going to do is take the user question, what we call the user utterance, and it's going to understand it. And to understand it, it needs to parse that sentence. So I want to book a flight is the user intent, what the user wants to do. And then we have a couple of contextual information that we call entities. For example, an entity is a destination, or an entity is a time period. So if I want to go to Paris next week, those are individual entities that the agent is going to extract. So the customer has the intent to book a flight, and then this query, the user utterance, already has some information regarding where the user wants to go and when we want to leave. But the agent needs to decide what to do. Given this intent, the entity, and maybe the context of the conversation that maybe before that question, what would be the best answer? So the agent is going to look at the different tools, and within generative orchestration, we'll see how the way it works in a minute. But the agent is going to look at the different tools. Could be a topic, it could be an action, it could be an AI prompt or a connector, and execute that to accomplish what the user is asking. So here, it understands that the user wants to travel somewhere, but it's missing some information to actually search for flight. For example, the departure city and the travel class. So the agent is asking back to the user for that missing information. So that whole concept is key in generating a good conversation with the end user. And to do natural language understanding in Copilot Studio, we have different options. The first default one, or historic option, was the built-in model in Copilot Studio. So that was the out-of-the-box model that comes pre-trained with predefined entity like colors, size, time, cities, etc. This natural language understanding model is used to execute trigger. So when we used to create topics historically in Power Virtual Agent, before it was Copilot Studio, we added trigger phrases to those topics. So the natural language understanding model could understand those trigger phrases, understand custom entities as well, and decide which trigger, which topic to execute based on the user utterance and the user intent. But it was limited. You could only have one intent recognized per query. That model cannot be extended. And sometimes within the same query, if you have multiple cities, for example, the flight, I want to fly from Atlanta to Paris, both are cities, and that model could not extract like, okay, here's the city I'm living from, and here's the city I'm going to. For the agent, it was the same entity in both scenarios. So he couldn't really understand like the from and to kind of concept. Another solution for natural language understanding is to create your own model on Azure and then import that model in Copilot Studio. So the advantage with that is that it can support additional languages. You can further customize that model, so you can better tune it to recognize specific intent or to address specific industry requirements. It can do advanced entity extraction, like the same type of entity from and to. This kind of model can do the differentiation between the from cities and the to cities. So it's a little bit more advanced. But the downside of that is that you need to train it. It has separate cost on Azure. It also has some limitation in terms of single intent per query. And then you have to keep it in sync with your agent, meaning like the application lifecycle is a little bit more complicated. And finally, the third way of managing natural language understanding in Copilot Studio, and the one that we are really interested in today, is generative orchestration. So generative orchestration uses a large language model, GPT-4o. Actually, it uses multiple GPT model with different versions depending on what we're trying to accomplish. We'll talk about that later today. So it uses a different large language model to understand the user intent and extract the different entities. The advantage with those large language models is that they can understand complex utterance with multiple intent. So I can ask two questions in the same message at the same time, and the agent will be able to understand those two questions and treat them one after the other automatically. It can chain different actions and tools together, so it can use the output of a tool as an input of the next tool. We'll show you an example of that later. It can also combine knowledge with the execution. For missing input, large language model can ask questions automatically. We'll see how to use that in our context. We can allow correction when we send an information and we actually tell the model, actually, can you change this? And it's able to change the value that was previously sent to the model. And at the end, it can generate a unified answer based on the execution of multiple tools. So that's a lot of great features that the natural language understanding model are not able to do. On the downside, it's a little bit more expensive to use. It costs 5 messages, and actually now we are not talking about messages. We are talking about Copilot Studio credits. But same applies. We didn't change the cost. It's just not messages, it's credits now, of course. So it's a little bit more expensive, but since it can do more, I would say that the cost compensates, like all the value that you bring with that new feature compensate the cost. And we'll see an example of why and how you can leverage the most of that large language model that does the orchestration to generate answers as well, because it's very important to understand how you can do that. It has a limitation of number of tools it can orchestrate. So when you turn on generative orchestration, a tool is a topic, an action, an AI prompt, knowledge. So all those tools, we have a limit of how many you can orchestrate, but we'll see we have different ways of mitigating those limitations. All right, so let's dive into the architecture to understand how that works inside Copilot Studio. So if we look at an agent from a high-level perspective, let me draw that laser pointer here. The agent is part of several bricks, okay? At the bottom, you have those foundation models. So now an AI model is a commodity. It's something that is available, and we're going to use it. We're going to send a prompt, get an answer. It's just an API. It's something that I query, I get an answer. The real value in Copilot Studio, in my opinion, is the orchestrator, because that's the system that can connect your knowledge, your tools, plan generate the plan of execution, manage the exception, handle the triggers, call the foundational model, the foundation model when needed. So this is the key element in Copilot Studio, and this is where you have the most influence with instruction in how your agents are behaving. At the top, you have a user experience. It says it's optional because technically, autonomous agents don't have a front end. They don't have a user experience layer. They run in the back end. So an agent doesn't necessarily mean a conversational agent. And today we'll cover both conversational agent and autonomous agent within the context of that generative orchestration topic. And here on the right, we introduced multi-agent architecture at the beginning of summer. So one agent can be actually a component of another agent, either as a connected agent or as a child element, and we'll see what that implies in this presentation. And since I don't want to go into too many details and slides, I'm going to jump into our first demo of the session, which is going to be around conversational agent. All right, I'm hoping that everybody still see my screen. And let me check the chat. Yes, okay. All right, see my screen, Ashley?
Yes, we can see.
Fantastic. All right, so let's take an agent, a conversational agent, within the context of generative orchestration. So first of all, the first thing that you need to turn on if you want to use generative orchestration is this piece. You want to enable generative AI to respond to the end user. So that's how you turn on generative orchestration in your agent. You can select a response model. We see that currently we use a GPT-4o model. If you go to the settings, you can actually select a different model. The GPT-4 mini is in preview. Once it goes GA, it will replace the GPT-4o. You will still be able to switch back to GPT-4o for backward compatibility reason, but at some point we will offer GPT-4 mini as the new default model for response generation. Okay. So back in my agent, once I turn on generative orchestration, the most important thing to do is to start crafting your instructions. And those instructions are going to be working in collaboration with the different tools and topic and knowledge that you're going to add in your agent. So you will typically work through writing your instructions at the same time you would add the different tools that you're going to need. So if I take my instructions overview, so first I will define some tone and personality, I want to say, to my agent. So I'm telling my agent that you're an IT and HR agent helping employee to be, I want the agent to be friendly and use emojis. That's the tone I want to my agent to use overall during the conversation with the end user. So it's something that is globally applied. I added a tool to create incident, and we'll see later when can I use this tool. Sometimes large language models are a little bit confused as to when to use a particular tool. So in your instruction, if you click on edit, you can actually access the list of tools and topics and other agents that are available within your agent if you type / in your agent, meaning you can use that to specifically address or add context around a particular tool. So my create ticket incident, I'm telling my agent, I'm instructing the agent to only use that if the user specifically asks to create a ticket. Because I've seen that in the past, if I ask, I tell my agent, I have an issue with my laptop, the USB is not working. The agent may want to try, the large language model may understand that, hey, the user is having an issue. There is a tool that is here to create a ticket to ServiceNow. I may want to execute that. But actually, I don't want the tool to be used unless the user specifically asks to create for a ticket. I want the agent to use its knowledge to try to answer all those troubleshooting questions first. So giving context to how and when you use a tool is going to be key in your instruction. Another example of generative orchestration is to give context of things, to give instruction to the agent of things you need to do before or after certain scenarios. So, for example, if someone requests a new equipment, like a new laptop, I want my agent to verify that we have the right user profile in our database, because once I ship that new equipment to my employee, because my employee is working remotely, I need to make sure that the address is correct. So I can influence the plan generation. So I can influence how the large language model is going to decide which tool to use first by adding instructions regarding this particular scenario. So before I request the new equipment, because I have a tool to request new equipment, before I do that, I want to make sure that the agent check the user profile. And by doing that, it means I can have multiple tools that can be reused at different places, because one way could be, hey, in my request new equipment topic, inside that, I could build the check, the logic to check the user profile. But that means it's tied to this particular tool to requesting new equipment. Maybe the user wants to check its user profile because it needs to update its its shipping address or its emergency contact. So by decoupling the different tools and telling the orchestrator to use a combination of tools in certain scenarios, you make your agent much more flexible. Another way to use generative orchestration is here. It's to how to answer your question. So here I'm saying, whenever you go to your knowledge base tool, where you can search through HR and search through IT to respond to the user query, both of those topics are actually connected to ServiceNow instances. And I want my agent, when it responds, to give me a link to ServiceNow dynamically to the right knowledge article. So for that, I'm instructing my agent to add a link to the ServiceNow knowledge base at the end of the response by concatenating the knowledge article ID that we are going to retrieve from ServiceNow to my ServiceNow instance URL. So here I'm putting my ServiceNow instance URL directly into the instructions, but technically I can use, if I click on edit, I can use a variable. So here I can go to my variable explorer and see environment variable and system variable and global variable. So I could have my ServiceNow instance be dynamically changed based on the environment I'm working on, for example. So you could imagine pointing at a different ServiceNow instance depending on your life cycle of your agent. And then, so that's another way to use generative orchestration, is to influence how the answer is generated. And then finally, I'm using my generative orchestration and the instruction that goes with it to add instruction to add to influence how my agent is going to use individual tools as well. So I added a tool to send an email. And that tool, by default, it's a connector. It can send an email to someone. It can take body in HTML, or it can take body as plain text. So I'm instructing my agent to use HTML when using that tool. So it can generate dynamic HTML content, pass it to the connector in the body part of my agent to make the email a little bit more appealing. But one thing that is important is that generative orchestration should not be used for everything and anything. For example, for the send an email scenario, I don't necessarily want my user to be able to tell the agent to send an email to anybody in the company. Otherwise, I'm going to open the door to people spamming anyone with that agent. So sometimes you don't want generative orchestration to change some input and output, or more likely input, of some of the tools that you want. A perfect example for that is the input for the email here. That was awful. There you go. The input for the email. I don't want my large language model to change that, because otherwise the user could say, hey, send an email to whoever with that information. That could be risky. So I can decide to not let the generative orchestration handle that part and create my own logic. So in that scenario, I'm forcing the agent to use the user email address as the input name of this particular tool, so that I can only send emails to myself. And we'll see in a moment an example of that. Okay, so I've added my instructions, I've added some knowledge, I've added some tools, including create a ticket here and sending an email. You can see the description of my tool, and some values are hard-coded or decided by by the developer, by the maker of that bot, or some values are dynamically filled by the generative orchestration. So it's important to understand when to let generative orchestration do that, and when the maker needs to make a decision on what to send as an input. So let's give this agent a try and see the influence or the effect of my custom instruction on this agent. So I'm going to request a new laptop. I'm a new employee to the Contoso company, and I told my agent, before somebody requests any equipment, then you need to check the user profile. So I can see here already the logic working. I need a new laptop. In my topic, I do have request new equipment tool, but here my agent is executing the check user topic tool first. My check user topic tool is going to database with the user email, retrieving, you can see the input here, the user email, which is fetched because I'm authenticated. You can see the agent is greeting me by my fake name, Thomas. And so I'm authenticated in that agent, and it's able to pass the user email, which is in the user profile, and respond the information about that particular user. So that's something that I instructed my agent to do before doing any other task. And I didn't have to tell my agent like a laptop is a new equipment. The large language model is able to understand that kind of context. So everything looks correct. I say yes. And now my agent is going to keep going to the request new equipment. So you can see my topic, request new equipment, is being executed. In that topic, I ask the user what kind of laptop do they want. So I'm going to use a Surface Pro 15. And you can see here it's going inside my topic. When do I want this particular laptop? Okay, I want it for next week. And I'm going to submit that request. And it's going to create an approval to my manager in Power Automate. And then it's going to wait for my manager to approve that. Once this is done, then I can see here in my activity tab, I can see that I have a new request waiting for my approval, waiting for my manager approval to request a new laptop. But that's not really the case. Okay, so once it has done this approval request, so it's pending. I'm returning to my agent because the agent cannot wait for an approval. That's something that we'll discuss maybe another time, but an agent cannot wait for an approval because it can only wait for 100 seconds. Okay, that hasn't changed. So I'm sending my approval request and then I'm returning back to my agent. And then here you can see it's asking end of conversation survey. Did that answer your question? And it's funny because this is typically executed at the end of a topic, but you can see that my check user profile did not trigger at the end of that topic. We did not trigger the end of conversation topic. So if I go to my end of user, my check user profile topic here, where I was executing at the beginning, check user profile, I did not redirect my end user to the end of conversation survey. And I did that in generative orchestration. It's a little bit tricky to do that. And I'll explain that in a second. But I'm using a mechanism to decide whether or not I want to ask a survey to my end user. So for some topic, I don't want to ask the survey. So I will set that global variable to false. And for other topic, I may want to ask the user a survey, for example, the request new equipment. I want to do that at the end of this scenario. And I'll show you later how to do that in generative orchestration. Actually, I can show you that now because it makes total sense. So at the end of my request new equipment, you will see that I have this global variable that I set to true. So meaning I want to get a survey from my end user. It's a little bit slow to load. Okay, so here I'm asking, I'm setting this value to true. And in generative orchestration, I'll cover that in a minute, but we have new topics, new triggers, sorry. One of them is on plan complete, meaning at the end of execution of a plan, I can decide to do something. And you can see that in this trigger, I'm testing if I want to ask the global survey yes or no. I'll dive into that particular feature in a moment. So here, okay, I'm at the end of the conversation. Did that answer my question? So that's the typical end of conversation survey. Yes, it did. Then it's going to ask me, okay, the rating for that particular experience. Okay, great. So I've ordered an equipment. My manager is going to review that, and then come the time, I receive my equipment. So can I help you with anything else? I'm going to say yes. So I received my new equipment, and unfortunately, the USB port is not working on my new PC. So I'm asking the question, and here it's not going to create a ticket for me. It's going to try to help me resolve that scenario. So I'm executing an IT knowledge base. So in this scenario, it's a topic where I describe the topic as answering any kind of question related to laptop troubleshooting, etc. So here it's going to fetch knowledge from ServiceNow, and I want to show you how I did that, because it's very important to understand that the large language model, the one that is doing the orchestration, can not only orchestrate the different tools to execute, but it can also be used for the answer generation. So what I see customers do typically for my search IT knowledge base is they retrieve data. So let me jump to that particular topic. They retrieve data from an API, which could be ServiceNow or whatever, and they take the user query, call a Power Automate flow, or maybe call a connector, and then so here, for example, I see my action. Oops, I see my action where I call my ServiceNow connector, and typically customer will take the answer of ServiceNow and then pass this to either an AI prompt to generate an answer out of this, or have to pass the JSON schema that is coming back from ServiceNow. So it's a little bit of complexity to just generate an answer. Using an AI prompt means you don't have to pass that JSON schema, that JSON payload that is returned from whatever API. But if you use an AI prompt, you're going to have to pay for it. You're going to use credit because you have to select a large language model in your AI prompt. And when you execute that prompt, it costs credits. You should not do that. Instead, you should return the payload to the large language model doing the orchestration using a topic output. So in here, I'm adding a topic output and I'm sending the response from my knowledge base. So you see that variable, the KB array variable coming from my Power Automate flow. I'm returning this to my agent. So if I look at the activity map, this is what I'm returning. I'm returning the raw payload from ServiceNow to the large language model responsible for the orchestration. And if I do that, then all of a sudden, I can use those specific instructions that I gave my large language model at the top level to influence the message being before it's sent to the user. And you can see here my large language model use the payload and use those instructions to generate dynamically that link to my ServiceNow instance. So if I click on it, so here I have my hardware troubleshooting for my USB not working. If I click on this, and of course my ServiceNow instance timed out, so I need to relog into my instance. It used the knowledge-based article ID, passed that to the large language model. The large language model was able to understand, okay, here's the knowledge-based ID for this, and generated that URL specifically for me on the fly. I didn't have to code, pass that KB ID, send it to a variable and manipulating that URL to create that for the end user. My large language model is able to do that on the fly just for me. So it's a very, very powerful way of generating answer and using generative orchestration in that context. Okay, so another way of another benefit of the generative orchestration is that it's aware of the entire context of the conversation. So if I say, okay, I tried all that, is it working? Let me go back to the activity map. Okay, so here I'm going to tell my agent, okay, I tried all those troubleshooting steps, but it didn't work. Can you create a support ticket for me? So now I'm explicitly asking the agent to create a support ticket. And you can see here, it found the right tool to create the incident. And that incident, that creating that support ticket, it has a few inputs. And those inputs were automatically filled by the large language model. So in generative orchestration, the large language model can detect, okay, the user, okay, this is hard-coded. This is the user email. I got this. The description, well, I'm going to summarize what the conversation is about and use that as the description of the support ticket. Same thing for the title, same thing for the urgency. So the large language model is assessing on the fly what is the urgency, what is the title, what is happening between the agent and the end user. So here it suggested, okay, here's the ticket I think you want to create. Is this correct? Yes or no? So I still have a final word. So I can say, actually, this is very urgent. And without adding more details or what you should do when it's very urgent, you can see that the urgency of the support ticket went from 2 to 1, which is the highest level of urgency in ServiceNow. And I didn't have to retype all the description or re-execute the entire topic to change just one value in my answer. And once I'm satisfied with that, I could change the description. I could add to the title or anything just with one question, like one message from the user. But if I say yes, then it's going to execute my ServiceNow connector, create that ticket for me. And if I jump on ServiceNow, you can see that the urgency has been set to high, and the description is a summary of what happened with my between my agent and my end user by leveraging the context of the conversation within generative orchestration. So it's pretty cool. It can help me, execute tools and fill the blanks for all those tools. And the final thing I want to show you where generative orchestration is really, really powerful, since it has all of the context of the conversation, you could ask something like, can I get a summary of this conversation via email? So in my tool, I have a tool to send an email. And if I ask the large language model, get me a summary of this conversation, it's going to use the entire context of the conversation because it's in that, in its memory, and it's going to execute the send an email action. And you can see here, it uses HTML, just like I asked it, and it gave me a summary of everything that happened between the agent and I. So it's a high-level summary. But if I go to my email and I look at my mailbox, I should receive. My session has expired. I need to re-sign in. Okay. I should receive an email. There you go. So I see I have a very high-level summary because the large language model decided to summarize it in a very short email. But I'm able to get the conversation context sent to an email by just adding the send an email tool and telling my large language model that, yeah, they can send an email with that. So very powerful way of leveraging generative orchestration in that context. All right, so that was a first demo. Now let's unpack everything that we've seen in that context. When the user is asking a question, the large language model in generative orchestration is going to generate a plan. So that's what we see in the activity map. It's what the model wants to execute. It can be topics, it can be action, it can be also knowledge. And the large language model is going to execute those action, knowledge, and topic in a particular order, depending on what the instructions are telling the model what to do. For example, I wanted to check the user profile first before executing the request for new equipment. So I'm influencing the plan generation at this point with instruction. And once the large language model has designed the plan, executed that plan, then it generates a unified response with the output of those different tools. Of course, if no tools are available, then there is always a way to execute the fallback topic. It's still there, so it can handle a question or it can handle scenarios where the large language model is unable to help the end user. So in our demo, I talked about how are tools and topic orchestrated. So it's really important to understand what you can do and where to influence that orchestration layer. So the first is to guide the agent when to call topics and action. You have two places where you can do that. The agent instruction, I showed you executing that tool before executing a particular topic. So I'm guiding the agent on when to do that. And also topic and tools, name and description can influence when to use which tool. For example, the send an email, the name is send an email, the description is use this tool when the user wants to send an email. So it gives indication to the model when to use that. Then we want to guide sometimes when the agent is using knowledge. Right now, it's in the agent instruction, but we cannot tell specific sources. So we can just say, use your knowledge to answer any question related to IT, but you cannot say, use this particular document. That's something that we are working on, and that should come to the product at some point later this year. Guiding the agent on the response formatting. My example with ServiceNow, where I want to inject a URL that is dynamically generated, that can be done in the agent instruction at the top level. Or if you use a topic and a generative answer node, you can also put instructions directly at the node level. But that is not related to generative orchestration. It's just how generative answer work at large. Then guiding the agent on how to populate input and output. That is going to be in the input and output description. We'll talk about that in detail in just a minute. And then finally, guide the agent on which knowledge source to use. We can use the knowledge source description, but right now this is only used if you have more than 25 knowledge sources. That is something that is not really documented anywhere, but you will see that knowledge sources are used opportunistically by the agent. We are working to bring more stability and consistency into when the agent is picking which knowledge sources later this year as well. So best practice for our instructions, ensuring that the instructions are grounded into action and knowledge sources. And for that, we can use the / for the tool names, the variables, and using PowerFX. Define your constraint, the response format, and guide how the agent is going to respond. That's in your instruction at the top level. Determining which action and knowledge to use and when. That's when you want to use accurate name and description, and actually names are more important than description. So you should not call your topic or your tool ServiceNow. You should call it create a ticket to the support team, for example. Specific knowledge cannot be named explicitly. We are bringing dynamic filtering soon. We don't have a clear ETA on that, but we're working on it. And finally, for autonomous-based agent, we are going to see that at the end of the session today. Defining a sequence of action can help bring stability in our agent. That with the combination of specific prompts into the tools, specific instructions into the tools, each of the tools. Let's dive into topic input and topic output. So if you remember in my demo, I mentioned I use topic input. So if I go back to my demo just to quickly show you that, in my search IT knowledge base, I had an output in this topic. So I'm using the topic as a tool which has input and output, and the output is the return of my ServiceNow payload. So it's a unstructured, it is a structured JSON, but I'm lazy. I don't want to pass that JSON, and if the JSON change, my schema is going to break or anything. So what I do is I use the topic output, send that payload as is to my large language model. And the beauty of large language model is that they can make sense of all that gibberish and all that JSON with no problem. So we can leverage the large language model to make sense of that and then generate a clear answer for the end user. You can see here, it used bullet points, it used list, steps, and it generated the link at the end. So I was saying, topic output, my large language model, I return that JSON payload directly, and I don't need to deal with it. The large language model is going to generate that nice looking, answer here based on this awful JSON snippet. So perfect large language models are perfect for that. So to do that, we use topic input and output. So topic input and output are a little bit hidden if you've never seen it. So if I go to my about any topic, so let's take one with an output. My IT knowledge base, you have to click on the details icon here. Oops. The detail icon here. And once you click here, you have the detail of your topic at the beginning, but you also have those two tabs, input and output. So for this topic, I don't have an input, but I do have an output. And in my output, I'm using the knowledge-based array here and sending that payload back to the large language model with a description. That's very important because that will tell the large language model what is in that variable and how should the large language model use it in the context of our conversation. So the user asked a question, it went to the IT knowledge base, and then the variable description that's the response from the IT knowledge base. So the large language model is like, okay, I got it. I need to generate a response with that payload. So couple of best practices for topic input and output. So write a clear description, use example if you want. You can explain if the data needs to be extracted or manipulated. You can use list of values if you want to have data validation. So, for example, in a topic input, you can say, "Hey, only accept, if it's a T-shirt size, only accept small, medium, and large." So, if the user say, "I want to order an extra large T-shirt," it's not in the list. The large language model is going to reprompt the user, "Sorry, as an input, I can only accept like small, medium, and large." So the large language model is able to do that for you. You can also, use example like, "Hey, for ServiceNow, I'm expecting a ticket within that kind of, formatting." We don't have custom entities right now. It's something that is not supported at the moment. We are working on it. So the identification here only uses pre-default or pre-built entities or the entire user response, which you can combine with some instructions that are in the description to extract particular information. Same thing for topic output. We want to use the topic output to send it to the orchestrator to generate a response to avoid paying double. So using an AI prompt and using the orchestrator to generate a response, you will pay twice. And also, you may also end up with two answers, one generated by your topic or your tool and one generated by the LLM. To avoid that, you can use the end all topic at the end of your topic, which is what I was doing here in my search IT knowledge base. I was ending my topic to avoid the, if I were to send a message inside my topic, if I use end all topic, it will avoid the large language model at the top level to answer again the user question. So ending all topic is when you want to generate manually a message to the end user instead of leaving the top orchestrator generate a message like I showed you in my example with ServiceNow. There is a new feature for generative orchestration, which is the new session outcome. This went out just this week, so it's very recent. You are the first one to hear about it. So in generative orchestration, outcome of the sessions in analytics were often abandoned because we were waiting for the user to, take the conversation survey, and the user was not doing it. So it was going into abandoned session. Now, after 15 minutes of inactivity, if there is no active plan in the generative orchestration planner, then we will consider the session resolved. If there is a question that the user is expected to answer, like, can I help you with anything else? Actually, that's a bad example because this one will resolve the conversation. But if I were to ask the user, like, give me the departure date for your trip, the user doesn't provide the answer, then we automatically consider the session as abandoned in generative orchestration. So it's a great new feature that will improve overall analytics in your generative orchestration agents. Everything that I'm presented so far, they are available on the new page of Microsoft Learn. We just published a lot of guidance for generative orchestration. Part of the content in that presentation actually comes from that page. Feel free to go and check it out. It explains a lot of how to build your instructions, how to use tools and topics and topic input and output as well. All right. During the initial demo, I mentioned that we have new triggers for generative orchestrations. And I'm sure many of you are not aware of those new triggers. We actually have 3. 2 are officially available, and 1 is kind of secret. So let's go and cover those 3 different triggers. The first one is on knowledge requested. The second one is AI response generated. And the third one is on plan complete. The order of those triggers is first, executing the knowledge request, second, the response generated, and third, the plan complete. So let's dive into those 3 particular triggers. So the first, I'm talking about the on knowledge requested. It's actually a secret trigger. It can be enabled if you use the YAML view, you switch to the code view in your topic, and you select on knowledge requested. So that trigger is executed after knowledge has returned data from search. Inside that topic, you can access different information about the answer, or about the knowledge that is being retrieved in your agent to manipulate the search result of your knowledge. So if you were to enrich those search results, you have a variable called search result. It's a table. You can add value to that by calling an API or add any kind of value that is coming from outside of your agent to enrich the data, to add your own custom data within knowledge execution. So you can combine your own custom data with knowledge retrieved from regular knowledge sources like SharePoint or some documents. So it can be used in very specific scenarios. It's not necessarily the most common trigger to use when you use generative orchestration, but it's there. I wanted to share that with you. The second topic that is very important is the AI response generated. So this one is triggered after the AI response generation and before we send the message to the end user. So that's a great tool when we want to enrich the responses or change the citation links. Here I'm pasting a link to our GitHub repo to show you an example of how you can manipulate link within that topic, and I'm going to show you a quick demo with that. At the end of this topic that is using the AI response generated, you can decide whether or not you want the orchestrator to respond for you, or if you want to manually send a message. So you have a variable and a variable part of that particular topic called continue response. It's a system variable. You can set it to yes or no in that context. So let me show you that in action. So I'm going to switch to another agent. I worked with a nonprofit a few months ago, and they added a lot of knowledge into their agent. And the knowledge were mainly PDF files for different languages. They didn't rely on SharePoint or anything. It's just public knowledge from a website or from documents. But if you were to ask a question about a document that you upload in your agent, you know that the citation links for those documents, it's a massive pop-up that is not necessarily, very nice looking for the user. It's raw, it doesn't have the formatting, it does not allow you to download the full documents, and you don't really see where the information, is coming from, because it's a poor experience. With my new topic, that is with my new trigger, which is on AI generated response, I'm able to capture the AI response generated and actually swap the link from the citation. Instead of pointing at this awful pop-up built in my agent, I'm able to point at a PDF, and in my scenario, a specific page of a PDF on a public website. So my PDFs are all in that organization website in a particular directory, and I want the end user to be able to view the entire PDF and download it and actually see where this information came from. So here I ask a question about what is the immigrant safety plan for that nonprofit who is helping, immigrants with their children. I can see here I have a bunch of citations, and they look exactly like it was a citation coming from my different knowledge sources. But if I click on it, instead of opening that awful pop-up, it actually takes me to their website and actually to the page that contained that information. So it's a much improved user experience by leveraging that generative orchestration trigger. And this code sample is available on our GitHub repo. So you can see here at the top, I'm leveraging the new, there you go. I'm leveraging the new AI response generated. You can switch trigger by clicking on that small double-sided arrow here, and you scroll at the bottom. You see those two new triggers for generative orchestration. All right, back to my slide. On plan complete, that's the third trigger. This one is executed after the orchestrator has finished executing its plan and sending the response. It's just what is the last step I want to perform in my agent. In generative orchestration, it's typically used to redirect the user or to the end of conversation topic. You can see here, I have a global variable that I set in my different tools and topic. And when that variable is true, then I want to redirect the user to the end of conversation. So it gives me some flexibility to not systematically execute the end of conversation topic, and also not having to hard code that end of conversation in all of my topics. And sometimes I don't use topics, sometimes I use tools, and I want that at the end of the tool execution, I want to go and execute my end of conversation topic in certain scenario. So the on plan complete trigger is great for doing that. So by now you understand that mastering generative orchestration is key, because it can do a lot of things for conversational agent, like we've seen, but it's also the key element for autonomous agent, because autonomous agent needs to independently generate a plan and execute that plan based on the set of instructions and rules. We cannot rely on an interactive experience with the end user. So autonomous agents are powered by generative orchestration, and they cannot go one without the other. Another new tool that requires generative orchestration is multi-agent. If you want to have multi-agent, you need to enable generative orchestration. That allows you to pick agent based on their description, because they can be connected to your agent, and the large language model can decide to delegate some task to those agents. So an agent can be a connected agent, so it's outside of your solution, or it can be a child agent that acts just like a tool within your own agent. So if we look at this architecture for agent, one way is to put your agent inside your overall Copilot Studio. So that's what we call child agent. Those are great to do some kind of manipulation on a particular data structure, or they want to follow particular instructions. They have their own knowledge, they have their own tools inside those agents, and they are part of your solution. So when you move and extract your agent and move it to another environment, those child agents follow the ALM pattern. And the other tool that is available is connected agents. Those are outside of your solution. They are maybe external to Copilot Studio, because you can connect M365 agent and Azure Foundry, and very soon Fabric Data Agent. It's in preview. So those are outside of your Copilot Studio agent. They can have their own application lifecycle, but if you allow those agents, they can be connected to other existing agents in Copilot Studio, which is what we're going to do and see in this last demo today, where I'm going to combine autonomous agent running with generative orchestration with connected agents. Ashley, I know we are good on time, but I'm keeping an eye on the clock.
Fantastic.
So for this use case, I have a conversational agent, which is my stock policy agent. It can answer questions about my inventory level around an IT department. So it has some knowledge of the stock policy. How many laptops do I need to keep in stock? Who's the vendor for those laptops? What is the lead time for those laptops, etc. And then I have an IT inventory table, which is basically a data model that contains some information about what equipment do we have in stock, how many do we have in stock, etc. What is the price of a single laptop, a single mouse, etc. So it's an agent for my IT department, to monitor stock and ask questions about the different stock policy. So it's a conversational agent, but that agent, I went into the settings and I said, other agent can connect to this one and use it for various reasons. So that's interesting. It means I can take that agent and use it in other agents. And in my scenario, I wanted to create an autonomous agent that manage the inventory of all those devices for the IT department. So in my autonomous agent, in my different tools, you can see I added the stock policy agent. So it's going to be able to answer questions about stock policy based on the database table and some overall general knowledge in my agent. In my autonomous agent, you can see I'm turning on generative orchestration, and I crafted some specific instructions. So those are the business rules that I want the agent to follow. When you're running low on an inventory, check what is the minimum of order by calling the stock policy agent. So my agent doesn't have any knowledge about what is the current stock, what is the stock policy. I'm just delegating that responsibility to a second agent that someone else built. And then I'm adding some logic with different steps. When you need to order more quantity, use the minimum of order, calculate the total order amount. If the order amount is above $10,000, then create a request approval. If it's less than that, then just order the equipment. So I'm explaining to my agent my business logic. So let's give it a try with a test trigger here. So my test trigger is actually going to execute a Power Automate flow. And that Power Automate flow is going to look at my inventory and monitor that table and send a prompt to my agent when something is happening. So you can see here, I have a prompt that is running, and that prompt has been carefully crafted. And I will explain that to you in a second. I'm just going to leave that execution go for a second. You can see first step is going to call my stock policy agent, which is going to search its own knowledge. So the database table, the different PDF that are in there. You can see my minimum of order is being returned to my main agent. And here it's automatically going to the next step. So it's going to order more equipment, and then it's going to generate an email at the end of those scenarios. So let's pause for a second and go from the beginning. What is really important when you use generative orchestration and autonomous agent is that the prompt that you send to your agent should be crafted very carefully. It should not be the default prompt when you add a trigger to your agent. So if you were to add, create a trigger here, it's going to create an empty Power Automate flow, just this one, like this one, where you have a particular trigger, and then it has a default prompt. You can see that I changed the default prompt to inject context based on the database table I'm monitoring to my agent, because my agent has no idea of what's going on in that database table unless I tell my agent what is going on. So here I'm saying we are running low on inventory for this particular equipment. We only have that many in stock. Here's the unit price. Here's the lead time. So I'm giving a lot of context to my agent so that when it runs, it knows that, oh, we are running low on stock. It's for laptop. Here's the price of a laptop. So it automatically calculates everything that needs to be done, and then follow the guardrails and the instructions in your instructions. So that's how you combine an autonomous agent and a connected agent. I'm just going to jump quickly to my presentation, and then we'll open up the floor for a question. As a conclusion, by now, you all understand that, yes, generative orchestration rocks. It can chain multiple tools. It can create that unified answer from complex scenarios. It can detect multiple intent. I didn't show it today in the demo, but if you were to ask multiple questions, it will answer all those questions at once with that unified answer capability. Using topic input and output is going to be a key to leverage topics and tools. And when you use topic input, if the context of the conversation and the large language model is not able to fill the topic input automatically, then the large language model is going to dynamically generate a question to me. What is the ServiceNow ticket that you're looking for? Because there is no ServiceNow ticket in the conversation context. So it's able to use that topic input to dynamically generate a question. And then, of course, it's the foundation for multi-agent and autonomous agent, and it will get better and faster with newer models. But last slide, there are challenges. Today it worked pretty well, but it's highly dependent on the quality of your instructions and the tool description. So you have to be very careful on how you craft them. You have to iterate, try some instruction, tweak them a little bit, try again. So it takes a lot of trial and error, and it's not ideal. It feels like there is less control than the classic orchestration. It's true, but we are adding more with the new 3 triggers that I mentioned. It can be subject to hallucination. The main reason is usually when we use a topic to send a message and we don't stop the large language model to answer as well. The large language model really wants to answer, but we want to stop it there. So the mitigation for that is to end all topics that will prevent the orchestrator to generate its own answer. It has it doesn't have all the features that classic orchestration used to have or still have today, like the custom entities and the dynamic knowledge. We're working to bring parity to generative orchestration, so stay tuned. Between now and probably the Power Platform conference in October, you will see some new stuff popping up in the knowledge management in particular. It has a higher cost, but like I said, it brings higher value. So I think it mitigates that cost, and it has the limit of 128 tools, which can be mitigated if you break down that big agent into multiple connected agents. Just like the example where I have a connected agent calling an autonomous agent, calling a conversational agent to retrieve some information from other tools, so I don't have to overload one agent with everything available in my organization.
But yeah, bye guys. This is the end of the session. Have a good, thank you, Remy, and also Karima for jumping in, and thank you guys for attending. Have a good morning, noon, afternoon, and night, wherever you are.